Close your eyes, or keep them open. Either way, let your mind go somewhere old. Somewhere so old that every empire you have ever studied is, by comparison, a child taking its first steps. Go back 4,500 years to the edge of the Sahara, where the desert meets the sky, and where something stands that should not exist. It is not ruins, it does not crumble, it does not lean or sink or fade. It simply stands as it has stood since long before Rome was a village, before Athens had its agora, before the first stone of Stonehenge was dragged across the English plain. It stands with a precision that modern engineers describe not in feet or inches, but in fractions of a degree. In widths thinner than a human thumbnail. We call it the Great Pyramid of Giza. The textbook says it was built by Pharaoh Khufu, 4th dynasty, around 2560 BCE, using tens of thousands of workers, copper tools, and wooden sleds. The textbook is very confident about this. The stone, however, tells a different story. The greatest mystery in human history is not who built the pyramids. It is how we became so certain we already know. Tonight, we are going to slow down. We are going to sit inside the question rather than rush past it toward a comfortable answer. We will look at the mathematics and find them unsettling. We will look at the geology and find it inconvenient. We will look at the written record and find it, in one critical place, completely silent. And at the end, we will not offer you an easy answer, because the honest answer is still being carved, letter by letter, from the living rock of evidence. This is not a story about aliens. This is not a conspiracy. This is something stranger and more human than either. It is the story of a civilization that inherited knowledge it could not fully explain, built something it could not repeat, and left behind a monument that has quietly outlasted every theory ever proposed about it. Settle in. Let your breathing slow. The stone has been patient for 4.5 millennia. It can wait a few more hours. 3/20 of a degree. What that actually means here is a number, 3 arc minutes. Write it down if you like. 3 arc minutes. It is 1/20th of a single degree. On a compass, it is almost invisible. Hold your arms straight out, extend your thumb, and the width of your thumbnail covers roughly 2 degrees. 3 arc minutes is less than 1/10 of that thumbnail width. That is how far the Great Pyramid deviates from true geographic north. Not magnetic north, which shifts with the Earth's magnetic field and has wandered substantially since ancient times. True geographic north, which is fixed by the planet's rotational axis and can only be found by watching the stars over weeks of careful observation. 3 arc minutes. That is the total error across a base 756 feet long on each side. Modern surveying teams using GPS satellites and laser theodolites would consider this acceptable. For most buildings constructed today, this margin would not even be measured because the instruments used in standard construction cannot reliably detect errors this small. But here is what disturbs engineers and architects when they first encounter this number. The Great Pyramid was not built with GPS. It was built, according to the conventional account, using sticks, plumb bobs, water channels, and the naked human eye looking up at the stars. And it achieved, using those primitive instruments, a directional accuracy that most modern buildings do not match. 13 acres of glass now consider the foundation. The base of the Great Pyramid covers approximately 13 acres of limestone bedrock. On that 13-acre surface, the four corners differ in elevation by less than 1 inch. The southeast corner is about half an inch higher than the northwest corner. Across 756 feet of ancient stone, the builders achieved a flatness that professional surveyors in the 19th century measured and could scarcely believe. To understand what that means, imagine trying to level a surface the size of 14 football fields. Not approximately level, not close enough, flat to within the thickness of a few stacked coins, over a distance of nearly a quarter mile per side. Now do it without a laser level, without a digital readout, without GPS. Do it in the desert, using water in channels carved into limestone, trusting the surface of still water as your only reference plane. It is possible. The physics of water leveling are real, but possible is not the same as explained. Because what we cannot account for is the obsessive commitment to an accuracy that nobody required. A pyramid that varied by 3 inches in its foundation would still have been magnificent. It would still have dominated the skyline. It would still have lasted thousands of years. The extra precision served no visible structural purpose, no decorative function, no requirement of the burial ritual that presumably motivated the construction. The precision exists because precision mattered for reasons we have not yet recovered. Someone cared about accuracy beyond what was necessary. That is either the mark of obsession or the mark of purpose we have not yet understood. The orientation problem true north is not found with a compass. It never has been, not accurately. Magnetic north wanders. In Khufu's time, the magnetic pole was in a different position than it is today, and the deviation would have been significant. To find true north, you must look up. Specifically, you must identify circumpolar stars, those stars close enough to the celestial pole that they never set below the horizon. You watch them over hours, over nights, over weeks. You mark the extreme eastern and western positions of their arc across the sky. You bisect that arc with perfect mathematical precision. That bisected point is true north. This process requires clear skies. It requires careful record-keeping. It requires mathematics. And it requires an understanding that the Earth rotates around a fixed axis, that this axis points toward a specific region of the sky, and that the positions of stars can be used to locate that axis with precision. None of this is magic, but none of it is simple either. It is a body of knowledge that, according to our conventional timeline, was not formally articulated in the ancient world for another 2,000 years. The Greeks, working around 500 to 300 BCE, developed the mathematics of spherical astronomy in ways that let us trace their thinking. We have their texts. We can follow their proofs. We cannot follow the proofs of whoever aligned the Great Pyramid, because those proofs were never written down. Or, if they were, they did not survive. What survived was only the result. A monument oriented to within 3 arc minutes of geographic north, precise enough that it serves today as a surveying benchmark for modern mapping of the Giza plateau. 3 arc minutes. It gets more unsettling the longer you sit with it. The mathematics nobody wants to do. Let us do the math that the textbooks tend to summarize quickly and move past. The Great Pyramid contains, by the best modern estimates, somewhere between 2.3 and 2.6 million stone blocks. We will use the middle estimate of 2.4 million. Each block weighs an average of 2.5 tons. Some, particularly the granite beams in the King's Chamber, weigh between 50 and 80 tons. The conventional timeline gives Khufu a reign of approximately 20 years. Most scholars allow roughly 20 years for the pyramid's construction. Let's use 20. 20 years is 7,300 days. Divided into 2.4 million blocks, that is 328 blocks per day. If we assume construction occurred only during daylight, say 12 hours per day, that is 27 blocks per hour. That is 1 block quarried, shaped, transported, lifted, and precisely positioned every 2 minutes and 13 seconds, continuously, every single day, for 20 years. This is not a rate that allows for rest. It does not accommodate the flooding of the Nile, which would have disrupted quarry operations for weeks each year. It does not account for the time required to set up the next course of stones, to survey the alignment, to check the precision. It does not include the hours spent just watching a stone swing on a rope to confirm it is positioned correctly before being permanently set. 1 stone every 2 minutes. For 20 years, with no mistakes, no delays, no learning curve, no bad days. The math does not forgive. The workforce that cannot be found. Herodotus, the Greek historian, writing around 450 BCE, nearly 2,000 years after the pyramid's construction, reported what Egyptian priests told him. 100,000 men, working in rotating shifts of 3 months each, for 20 years. This is our primary ancient source for the scale of labor. It is also a second-hand account, transmitted orally for 2 millennia before it was written down. The archaeology tells a different story. Excavations near the pyramid site, particularly at the workers' settlement known today as Hayt el Ghurab, revealed a community with bakeries, breweries, medical facilities, and organized dormitories. The food remains indicate a diet rich in beef, bread, beer, and fish. This was not slave labor. These workers were fed well, cared for when injured, organized into named teams, and apparently proud of their work. Graffiti left by work gangs used names like Friends of Khufu and Drunkards of Menkaure. But the settlement scale suggests a few thousand workers at any given time, not tens of thousands, not 100,000. Archaeologist Mark Lehner, who led the excavations, estimates a core workforce of perhaps 20,000 to 25,000 people during peak construction phases, with most of that number involved in support roles, such as cooking, hauling water, tool maintenance, and administration, rather than moving stone. A few thousand people actually moving and positioning stones. Remember the 2-minute per block requirement. Now divide that requirement among a few thousand workers, accounting for the fact that not everyone moves blocks simultaneously, and the numbers become genuinely impossible under the conventional model, unless the methods were dramatically more efficient than anything we have been able to reconstruct, unless there was something happening in that desert that our experimental archaeology has not yet successfully replicated, the ramp that isn't there. The dominant explanation for how the builders lifted stones from ground level to heights exceeding 480 feet is the earthen ramp. Workers would drag stones up a slope using ropes and wooden sleds, lubricating the sand with water to reduce friction. Experimental archaeology has confirmed that this method works. Small teams can move 2-ton blocks this way with reasonable efficiency. The problem is geometry. To reach a height of 480 feet with a slope shallow enough for workers to ascend and drag heavy loads, a ramp needs to be inclined at roughly 10 degrees or less. At 10 degrees, a ramp tall enough to reach the pyramid's apex would need to extend approximately half a mile in length. Its volume would be greater than the volume of the pyramid itself. Building the ramp would, in a very real sense, be a larger project than building the pyramid. And once the pyramid was complete, every stone of that ramp would need to be removed, leaving no trace. Ground-penetrating radar surveys of the Giza Plateau have found no evidence of a ramp of this magnitude. The bedrock around the pyramid does not bear the scars of a structure that size being built and then dismantled. Alternative proposals include internal ramps spiraling upward within the pyramid structure itself. Jean-Pierre Houdin, a French architect, developed a detailed model of this approach. The theory is elegant. It is also unfalsifiable with current technology, because the only way to prove or disprove it requires either penetrating the pyramid walls or finding unambiguous void signatures in imaging data. Muon tomography studies, which use cosmic particles to map density variations inside the pyramid, have detected anomalies, including a large void above the Grand Gallery. But whether those anomalies represent a ramp, an undiscovered chamber, or natural variation in the masonry remains actively debated. The ramp is not there. The ramp cannot be found. The ramp, in the volumes required by conventional models, cannot have vanished without a trace, and yet the stones are in place. The spiral that should not exist. In the 1990s, a researcher named Christopher Dunn examined drill cores extracted from granite at sites across ancient Egypt, including the Great Pyramid. What he found in those cores was not what copper tool drilling produces. The spiral grooves cut into the granite by ancient drill bits advance at a rate of approximately 1/10 of an inch per revolution. That means for every complete rotation of the drill, it cut 1/10 of an inch into granite. Modern diamond-tipped core drills, operating under significant mechanical pressure with high-speed rotation, achieve similar rates into granite. Copper tube drills with quartz sand as an abrasive, which the mechanisms proposed in the conventional account, produce spiral grooves at a rate roughly 500 times slower than what the evidence indicates. Let that number settle. 500 times slower. The grooves in the ancient drill cores are not consistent with slow, patient, sand-abrasive drilling. They are consistent with drilling that advanced rapidly under pressure, with a tool that engaged the stone aggressively rather than scratching it gently. Copper scratches granite. It does not cut it. The spiral grooves in the king's chamber say otherwise. Granite, a material that fights back granite, is not limestone. This distinction is critical and often glossed over in popular accounts of pyramid construction. The pyramid's exterior was originally covered in polished limestone, and most of the interior is also limestone. These are relatively soft stones. Copper tools, with enough labor and abrasive sand, can work limestone. Ancient Egyptian artisans demonstrably did so. Granite is another matter. Granite is composed primarily of quartz, feldspar, and mica. Quartz alone registers 7 on the Mohs hardness scale. Copper registers between 2.5 and 3. You cannot cut quartz with copper in any meaningful sense. Copper deforms against quartz. The abrasive sand used as an intermediary would work slowly, painfully slowly, but the rate of material removal would be a tiny fraction of what the drill cores indicate. Yet the king's chamber is lined with red Aswan granite. The ceiling of that chamber consists of 9 massive granite beams, each weighing between 25 and 40 tons, fitted together with joints so tight that the gaps between them are measured in thousandths of an inch. The sarcophagus itself, carved from a single block of red granite, has interior surfaces polished to a flatness that modern machinists who have examined photographs describe as requiring modern lapping equipment to replicate. One block of granite, cut from living bedrock at Aswan, 500 miles south of Giza, transported down the Nile on barges, moved from the river to the construction site, lifted to a height of 140 feet, positioned with millimeter precision alongside other granite blocks, without mortar, without error, and carved with tools we cannot identify. The unfinished obelisk, a confession in stone. At the ancient granite quarries in Aswan, partially carved into the bedrock, lies what would have been the largest obelisk ever attempted. It is approximately 137 feet long, which would have made it the heaviest single piece of stone ever cut by human hands. It was never finished. Partway through the quarrying process, the stone cracked and it was abandoned. The unfinished obelisk is one of the most important pieces of evidence in this entire inquiry, because it tells us that even the ancient master quarrymen of Egypt had bad days. Stone cracked unexpectedly. Projects failed. The obelisk is a confession, carved permanently into the bedrock, that these men were working at the absolute edge of what was achievable with the tools and knowledge they possessed. Yet the granite in the king's chamber shows no such flaws. No cracks, no voids, no evidence of stones that were inspected and rejected. Every beam is perfect. Every surface is flawless. This suggests a quality control process so rigorous that only the finest stone was allowed to complete the journey from Aswan to Giza, and a shaping process so precise that the acceptable margin of error was measured in thousandths of an inch. If that quality control process was happening at Aswan at a scale that produced the king's chamber, we would expect to find evidence of the rejected stones. Piles of cracked granite, abandoned attempts. The quarry floor should be littered with the failures that quality control demanded. the quarry floor does not tell that story. When the Sahara was green approximately 11,000 years ago, the Earth's climate shifted. The northern hemisphere's monsoon patterns strengthened dramatically, driven by subtle changes in the planet's axial tilt and its orbital shape. Rain fell across what is now the Sahara Desert. Grass grew, lakes formed. The Nile swelled to dimensions far beyond its modern channel. Animals that today live only in sub-Saharan Africa roamed freely across the northern continent. Humans, following the water and the game, spread across a landscape that was genuinely habitable. This period, which geologists and climatologists call the African Humid period or the Green Sahara, lasted from roughly 11,000 years ago to approximately 5,000 years ago. At its peak, it transformed one of the driest regions on Earth into what was functionally a savanna ecosystem, capable of supporting large, mobile human populations. Around 5,000 years ago, the monsoons retreated, the lakes dried, the grass died. The desert reclaimed its domain with a speed that, on geological timescales, was almost sudden. The populations that had spread across the Green Sahara were pushed toward the Nile Valley, the coast, and the remaining green corridors. It is not a coincidence that the first dynasties of ancient Egypt emerged at almost exactly the same moment the Sahara became uninhabitable. The people had to go somewhere. The Sahara was once alive. The people who lived there went somewhere when it died. We should ask where they brought their knowledge. Robert Schoch and the water that carved the Sphinx. In 1991, Robert Schoch, a Boston University geologist with expertise in stratigraphy and geomorphology, visited the Sphinx enclosure at Giza. He was not there as a mystic or a conspiracy theorist. He was there as a scientist trained to read the history of rock formations from the physical evidence left by weathering. What he found changed his career and ignited one of the most contentious debates in modern archaeology. The limestone walls of the Sphinx enclosure show vertical weathering patterns. Deep channels running top to bottom along the rock face, consistent with the sustained action of precipitation over centuries or millennia. Not horizontal striations, which wind-blown sand produces. Not surface pitting, which occasional rain creates. Deep rounded, vertical channels which require prolonged, heavy, repeated rainfall. Egypt has been arid for approximately 5,000 years. The last time the Giza Plateau received sustained heavy rainfall was during the African Humid period, which ended around 5000 BCE. If the Sphinx's enclosure walls show erosion from that rainfall, the stone was exposed to that rainfall. It was not buried. It was not untouched. It was carved, open, and sitting in a landscape that was receiving enough precipitation to erode limestone significantly. Schoch estimated, based on the depth and character of the erosion, that the core body of the Sphinx, not the head, which shows different weathering patterns consistent with later reworking, dates to somewhere between 7,000 and 5,000 BCE at the earliest, possibly older. This is not a fringe claim. Schoch is a credentialed geologist who has published in peer-reviewed journals and presented his evidence at scientific conferences. His methodology is standard geomorphological analysis. His conclusions are unpopular. but the evidence he presented has not been refuted on geological grounds. The refutations have come primarily from Egyptologists, who point out that no known civilization capable of carving the Sphinx existed in that time period. Which is precisely the point. The erosion, the models, can explain mainstream archaeology's response to Schoch's findings is essentially circular. The Sphinx cannot be that old because there was no civilization capable of building it at that time, and we know there was no such civilization because we have found no evidence of one. This is logically sound, but scientifically uncomfortable, because it uses the absence of evidence as evidence of absence, which is an error that the history of archaeology repeatedly punishes. Heinrich Schliemann was told there was no evidence Troy existed. He went to Western Turkey and found it. The ruins of Göbekli Tepe in southeastern Turkey were assumed by passers-by to be ordinary hillocks until Klaus Schmidt began excavating them in 1994 and found the world's oldest known megalithic temple complex dating to approximately 9600 BCE. Built by hunter-gatherers, before agriculture, before settled civilization, before everything we thought was necessary for monumental construction. Göbekli Tepe did not fit the model. The model adjusted. This is how science is supposed to work. The geological evidence from the Sphinx enclosure does not fit the model. The model in this case has been slower to adjust. Whether that is appropriate scientific caution or institutional resistance is a question each person must answer for themselves. When Orion stood at its lowest in 1994, Robert Bauval published a book called The Orion Mystery, co-written with Adrian Gilbert. The central claim was straightforward. The three main pyramids of Giza, the Pyramid of Khufu, the Pyramid of Khafre, and the Pyramid of Menkaure, are arranged on the ground in a pattern that mirrors the three stars of Orion's belt as they appeared in the sky around 10,500 BCE. The three stars of Orion's belt, Alnitak, Alnilam, and Mintaka, are not perfectly aligned. They form a slight diagonal, with the smallest and dimmest of the three offset to one side. The three pyramids at Giza are arranged in exactly this way, with the smallest pyramid, Menkaure's, offset from the line formed by the other two in the same direction that Mintaka is offset from the other belt stars. Bauval argued that the ancient Egyptians designed the complex to be a terrestrial mirror of the heavens, a concept he called the Orion correlation theory. More provocatively, he argued that the precession of the equinoxes, the slow wobble of Earth's rotational axis that shifts which stars appear where in the sky over a 26,000-year cycle, means the three belt stars were in a specific configuration close to due south in approximately 10,500 BCE. The Nile, he proposed, corresponds to the Milky Way. The response from academic Egyptology was swift and mostly negative. Critics pointed out that the correlation between the pyramid positions and the star positions is not as precise as Bauval suggested. That small discrepancies undermine the case for deliberate alignment, and that the date of 10,500 BCE is far earlier than any accepted date for the Sphinx or the pyramids. The stars move, the stone does not. The question is not whether the alignment exists, but why it exists with such care. The shafts that point at nothing accidental set the Orion correlation debate aside for a moment. Focus instead on what is undisputed. The shafts inside the Great Pyramid are astronomically oriented, and they were designed to be. The Great Pyramid contains 4 narrow shafts, 2 originating from the King's Chamber and 2 from the Queen's Chamber. They are not horizontal. They angle upward and outward, cutting through the pyramid's masonry at precise inclinations. For decades, they were assumed to be air shafts, providing ventilation during construction. This explanation has a problem. 2 of them, the shafts from the Queen's Chamber, do not connect to the pyramid's exterior. They terminate inside the masonry, sealed by limestone barriers that robotic probes have reached, but not penetrated. Air shafts that do not reach air serve no ventilation purpose. They serve something else. In 1964, Egyptian astronomer Alexander Badavi and Egyptologist Virginia Trimble published an analysis of the shaft orientations. Their finding: the southern shaft of the King's Chamber is oriented to point at Orion's belt at the moment of its lower transit across the meridian, as it appeared in the sky around 2500 BCE. The northern shaft of the King's Chamber points at the ancient pole star Thuban in the constellation Draco at the same epoch. Subsequent analysis by Robert Bauval found that the southern shaft of the Queen's Chamber was aligned to Sirius, the brightest star in the night sky, and the star that, in ancient Egyptian religion, represented the goddess Isis. The northern shaft of the Queen's Chamber aligned to a star in the constellation Ursa Minor. The probability of 4 shafts cut at precise angles through millions of tons of stone, simultaneously pointing at 4 significant stars by chance, is not 0. But it requires a kind of cognitive optimism about coincidence that is difficult to sustain when confronted with the engineering involved in getting the angles precisely right. These shafts were not easy to build. They were not decorative. They served a purpose that required astronomical knowledge and mathematical calculation to implement correctly. Sirius rising and the Egyptian year, ancient Egypt's calendar, was structured around a single astronomical event, the heliacal rising of Sirius. Once a year, after a period of invisibility during which the star was too close to the sun to be seen, Sirius reappeared on the eastern horizon just before sunrise. This event, called the heliacal rising, occurred in ancient Egypt at roughly the same time the annual Nile flood began. The flood brought the silt that made Egypt's agriculture possible. The heliacal rising of Sirius announced the flood. It marked the beginning of the Egyptian New Year. It was, for this civilization, the most important moment in the annual cycle of time. The star was not a decoration, it was a clock. To track the heliacal rising of Sirius over decades and centuries requires systematic astronomical observation. You must watch the sky every morning in the period before the expected appearance. You must record the date. You must do this for long enough to establish the pattern reliably, to separate the heliacal rising from weather-related visibility variations. The civilization that built the Great Pyramid and aligned its shafts to Sirius was not casually glancing at the sky. This was a civilization engaged in serious, long-term astronomical science, even if we would not have called it science by that name. How long had they been watching? We do not know. We do not know because their astronomical records, if they kept them in forms more detailed than the alignments built into stone, did not survive. The stone survived. The paper, the papyrus, the records did not. A civilization that wrote everything down ancient Egypt is, by a considerable margin, one of the most thoroughly documented civilizations in human history. The Egyptians wrote on papyrus, on limestone, on granite, on the walls of tombs, on the ceilings of temples, on pottery fragments called ostraca that served as ancient scratch paper. They documented tax receipts and grain inventories. They recorded legal disputes over land. They wrote down medical procedures with detailed case histories. They compiled mathematical papyri with worked examples of practical calculations. The Rind mathematical papyrus, dating to approximately 1650 BCE, contains 84 worked mathematical problems. It is a teaching document, a kind of ancient textbook, demonstrating calculations for areas, volumes, and proportions. It survives. We have it. It is in the British Museum. The Edwin Smith Papyrus, dating to approximately 1600 BCE, contains 48 detailed case studies in surgery. It describes head injuries, fractures, dislocations, and wounds with a clinical precision that reads almost like a modern medical manual. It survived. The Diary of Merer, discovered in 2013 at Wadi al-Jarf on the Red Sea coast, is a direct contemporaneous account from the reign of Khufu, written by an official overseeing the transport of limestone from the Tura quarries to Giza. It describes daily activities, boat movements, worker numbers, and the logistics of the operation. It is the closest thing we have to an eyewitness account of pyramid construction. It survived. They wrote down how to treat a fractured skull. They wrote down how to calculate the volume of a truncated pyramid. They did not write down how to build one. The engineering manual that does not exist at Merer's diary is fascinating and frustrating in equal measure. It tells us that limestone was moved from Tura to Giza. It does not tell us how the blocks were lifted into position. It does not describe the surveying method used to achieve the base's extraordinary flatness. It does not explain how the builders maintained alignment across 4 sides of the structure as it rose. It records the movement of stone without explaining the knowledge behind the structure. This distinction is critical. A shipping manifest and an engineering specification are very different documents. What we have from the pyramid's construction period is, in essence, shipping manifests. We know stone moved from point A to point B. We do not know why the stone, once at point B, ended up precisely where it is. The absence of construction manuals is not simply a gap in our records. It is, in its own way, evidence. Consider the pattern. For anything the Egyptians fully understood, documentation exists. Mathematics, documented. Medicine, documented. Agricultural management, documented. Religious ritual, extensively documented. The organization of labor, documented. The movement of material, documented. But the structural engineering principles behind the most sophisticated building project in ancient history, not documented, not referenced in later texts, not described by officials claiming credit, not preserved in educational papyri, not quoted in religious contexts. Simply absent. Absence does not prove impossibility. Documents can be lost. Libraries can burn. Papyrus can decompose. But the specific pattern of this absence, the extreme selectivity of what survived and what did not, invites an uncomfortable question. What if the knowledge was never written down because the people who applied it did not fully understand why it worked? Later pharaohs who would not claim credit. There is another category of textual evidence that tends to be overlooked: the writings of later Egyptian pharaohs, people who lived 1,000 or 2,000 years after the Great Pyramid was built, who describe their relationship to the monuments at Giza. And what they describe is not pride of heritage. It is something much more interesting. Thutmose IV, reigning in the 14th century BCE, had the dream stele erected between the paws of the Sphinx. In that text, the young prince describes the Sphinx appearing to him in a vision and asking to be cleared of sand that had buried it to its neck. The prince obeys, clears the sand, and is rewarded with the throne of Egypt. This is not the language a civilization uses to describe a monument built by its ancestors 4 or 5 generations back. This is the language of a monument that has already passed into the realm of the mythological, the divine, the inexplicably ancient. By the 18th dynasty, the Sphinx was already so old that the people living in its shadow had lost meaningful knowledge of its origin. Kamwaset, the son of Ramesses II, earned the informal title of the first Egyptologist for his work restoring monuments he described as already ancient and mysterious in his own time, the 13th century BCE. His inscriptions at Saqqara describe structures so old that their original purposes had been forgotten. He restored them, not because he understood them, but because he recognized they deserved preservation. A civilization's most famous monuments, treated by that civilization's own later rulers as objects of reverence and mystery rather than familiar heritage. This is either the long shadow of a deep antiquity, or something remarkable is happening to the transmission of knowledge across generations. The Zep Tepi. The first time ancient Egyptian religious texts contain a concept that translators and Egyptologists have rendered in English as Zep Tepi, meaning the first time. It refers to a mythological era at the very beginning of existence, when the gods walked the earth, when the principles of cosmic order were established, when civilization was founded by divine beings who preceded ordinary human history. The Zep Tepi is not a historical account. It is a mythological framework. But it is also, as scholars of comparative mythology have noted, a remarkably consistent and specific one. It does not describe the first time as a simple creation story in which nothing precedes it. It describes a first time that came after something else, an era of divine presence that established the patterns of knowledge and order that all subsequent history attempted to preserve. The Egyptians of the historical dynasties did not claim to have invented their civilization. They claimed to have inherited it, to be custodians of knowledge and order that originated in a time before writing, before recorded history, before the dynasties themselves. Every Egyptian dynasty believed it was the steward of something older. At what point does mythology become memory? The decline nobody expected if the conventional timeline is correct, and the fourth dynasty under Khufu represents the peak achievement of Egyptian construction capability. Then what follows should not be difficult to explain. Civilizations improve, techniques accumulate, knowledge compounds. The generation after Khufu should have built something as good or better. The generation after that, something more impressive still. The opposite happened. Khafre's pyramid, the second at Giza, is slightly smaller in absolute terms than Khufu's, though its position on higher ground and its retained casing stones at the apex make it appear approximately equal in scale. Menkaura's pyramid is dramatically smaller, roughly 1/10 the volume of Khufu's, constructed with noticeably different techniques and materials. The granite cladding on the lower courses gives way to smaller limestone blocks above a certain height. The precision is less extraordinary. Move forward one dynasty to the fifth, and the decline accelerates sharply. The pyramids of the 5th dynasty pharaohs, built within a century of Khufu's death, are structurally inferior. Their internal chambers are simpler. Their alignment is less precise. Several of them have partially or fully collapsed, not because of deliberate destruction, but because of structural failure. The Pyramid of Unas at Saqqara, completed around 2345 BCE, stands today as a pile of rubble that requires significant archaeological imagination to recognize as a pyramid at all. By the 6th dynasty, roughly 150 years after Khufu's pyramid was completed, Egyptian pyramid construction has declined to a point where the structures built in this period look, in comparison to Giza, like rough drafts. Their blocks are smaller, their precision is ordinary, their internal architecture is simple. Something was lost. The question is what, and when it was lost, and whether it was ever fully possessed. The inheritance hypothesis here is a model that fits the evidence without requiring supernatural intervention. Call it the inheritance hypothesis. The core premise is this: the technical knowledge applied at Giza during the 4th dynasty was not developed by the 4th dynasty. It was received, transmitted, inherited from an earlier source, possibly multiple sources, possibly over a very long period. The 4th dynasty, in this model, possessed remarkable organizational capability. They could marshal resources, direct labor, maintain discipline across a decades-long project, and apply knowledge they had received with sufficient skill to produce the greatest single construction achievement in the ancient world. But they were executing a plan, not originating one. They were building from knowledge that had been handed to them. Knowledge that they could implement, but perhaps could not fully explain in theoretical terms. When the generation of builders who held that transmitted knowledge died, what passed to their successors was not the complete understanding, but a simplified version. The form without the full theory, the procedure without the principle. Subsequent dynasties could build pyramids because they knew the shape and the general method. They could not build pyramids like Giza because they did not understand why specific details, specific proportions, specific alignments, specific construction sequences mattered. The knowledge became ritual. Ritual, transmitted over generations, simplifies and drifts. What begins as a precise procedure with understood reasons becomes a ceremony with remembered steps and forgotten purposes. The 5th and 6th dynasty pyramids look like what happens when you try to reproduce something you have seen, but not fully understood. This model explains the decline. It explains the silence of the texts. It explains why later pharaohs treated the Giza monuments with reverence rather than familiarity. And it raises the next question, which is the hardest one. Where did the knowledge come from originally? What the King's Chamber does to sound. In the summer of 1997, a team of researchers, including acoustic engineer John Stuart Reid and musician Merrill Doney, conducted an acoustic study of the King's Chamber inside the Great Pyramid. They were not the first to notice that the chamber had unusual acoustic properties. Visitors over the centuries had remarked on the strange way sound behaved in the room. The chamber seemed to amplify, sustain, and transform sound in ways that felt unusual. Reid's measurements confirmed and quantified what observers had long noticed. The King's Chamber is a natural resonator. Its dimensions, 10 cubits by 20 cubits by 11 cubits, create a space in which certain sound frequencies are dramatically amplified while others are dampened. The chamber's fundamental resonance frequency falls around 110 Hz. The room rings like a bell when stimulated at frequencies near this value. 110 Hz is in the baritone range of the human voice. A low, resonant vocal tone, not speech but sustained sound, hum, chant, drone, fills the chamber and returns from every granite surface simultaneously. The effect is described by visitors who have experienced it as immersive, enveloping, and deeply physical. You do not just hear the room, you feel it. A room made of granite, carved to a specific geometry, that turns the human voice into something that surrounds and penetrates you. Was this an accident? Or was this the point? The physics of sacred space acoustic architecture, the deliberate design of spaces to shape sound, is not unique to Egypt. The Paleolithic caves of Lascaux and Altamira, where prehistoric humans painted their most dramatic animal images, have been studied by researchers including Stephen Waller and Igor Reznikov, who found that the painted areas consistently correspond to the locations where acoustic standing waves, echoes, and resonances are strongest. The art and the acoustics coincide. Researcher Aaron Watson and David Keating studied the acoustics of Stonehenge and found that the original structure, with its missing stones restored digitally, would have created acoustic effects, including standing waves, echoes, and frequency reinforcement that are not present in the damaged modern version. The pattern is consistent across multiple ancient sites. The places where ceremonial activity occurred are the places where acoustic effects are strongest. Whether this is a discovery that the ancient builders made and deliberately exploited, or a universal human intuition that certain sounds in certain spaces feel sacred, cannot be determined from the physical evidence alone. But the correlation is real and measurable. The King's Chamber is not accidentally resonant. Its proportions, the specific relationship between its length, width, and height, produce its acoustic characteristics. Change those proportions, and you change the acoustics. The chamber was built to those specific dimensions with extraordinary precision in the hardest stone available. The acoustic effect was not a side effect. It was either the purpose or part of the purpose. The Grand Gallery, architecture in search of its function above the Queen's chamber and leading to the King's chamber, rises one of the most impressive interior spaces in any ancient structure in the world. The Grand Gallery. It is 153 feet long, 7 feet wide at the floor, and 28 feet high. Its walls are corbelled, each successive stone course projecting slightly inward, creating a narrowing vault that reaches a flat ceiling. The gallery rises at an angle of 26 degrees, the same angle as the ascending passage below it. The conventional explanation for the Grand Gallery's function is utilitarian. It served as a staging area for the massive granite plug blocks that, after Khufu's burial, were slid down the ascending passage to seal it permanently, preventing access to the King's chamber. This explanation accounts for the gallery's length and angle. It does not account for its height, its corbelled construction, or the remarkable quality of the stonework in what would have been a purely functional storage space. The Grand Gallery is not built like a utility corridor. It is built like a statement. The corbelled vault is structural sophistication applied at a scale and quality that serves no purely utilitarian purpose. The walls are finished with a precision that rivals the most visible surfaces elsewhere in the structure. Whatever its ultimate function in the construction sequence, the gallery was built to a standard that suggests it mattered in its own right. Several researchers have proposed that the Grand Gallery served as an acoustic amplifier, a designed space in which sound waves generated in the ascending passage were concentrated, focused, and delivered to the King's chamber in a specifically controlled form. The geometry of the corbelled vault would, in this model, act as a natural waveguide, shaping and directing acoustic energy upward. There is no consensus on this. There is not even much published research on it. The acoustic properties of the Grand Gallery have not been systematically studied with the same rigor as those of the King's chamber. The theory remains speculative, but the physics are plausible, and the architecture is compatible with such a function. The sarcophagus that was never used. In the King's chamber, against the western wall, sits a rectangular sarcophagus carved from a single block of red Aswan granite. It is lidless. It is unadorned. It bears no hieroglyphs. It contains no residue of oils, resins, or natron, the mineral compound used in Egyptian mummification. Chemical analysis of the interior has found no biological material consistent with the presence of a human body. The sarcophagus is also, notably, too large to have been moved through any of the pyramid's passages. Its width exceeds that of the ascending passage at several points. The sarcophagus was placed in the King's chamber before the ceiling was installed. It is a permanent feature of the room, not an object that could be brought in or removed. Whatever was intended to happen with this sarcophagus was intended to happen there, in that room, permanently. The conventional explanation for the absence of a mummy is tomb robbery, which is entirely plausible. Egyptian tombs were robbed systematically from very early in the historical period, and even the most carefully hidden royal burials like Tutankhamun's survived intact only through extraordinary luck. The Great Pyramid, being the most famous and distinctive structure in the ancient world, would have been among the first and most repeatedly targeted. But tomb robbers take treasure. They take jewelry, amulets, canopic jars, religious objects, gold. The lid of the sarcophagus, if it existed, would have been a valuable piece of polished granite that could be reused as building material. Its absence is explicable. What is harder to explain is the complete absence of organic residue. No oils, no resins, no salts used in mummification, no trace of the complex chemical process that Egyptian burial involved. If a body was prepared for burial in this room, or even simply placed here for a period, traces would remain. The chamber may never have been used for burial at all. Pi, phi, and the value of what cannot decay. The Great Pyramid encodes pi. This statement has been controversial for over a century, debated by mathematicians, archaeologists, and skeptics who point out that any sufficiently complex geometric form, analyzed with enough diligence, will appear to contain mathematical constants. The argument deserves to be taken seriously. Here is what the numbers actually say. The ratio of the pyramid's perimeter to its height is 2 times pi, accurate to 5 significant figures. The ratio of the apothem, the slant from the apex, to the midpoint of a base edge, to half the base length is phi, the golden ratio, approximately 1.618, accurate to several decimal places. These two relationships emerge from the same set of proportions, a base side of 440 royal cubits and a height of 280 royal cubits. The skeptic's response is that the builders chose aesthetically pleasing proportions without knowing they were encoding mathematical constants. And the constants emerged by coincidence. This is genuinely possible, but consider the full picture. The pyramid's height, multiplied by 43,200, approximates the Earth's polar radius. The pyramid's perimeter, multiplied by 43,200, approximates the Earth's circumference at the equator. The number 43,200 derives from the precessional cycle of the equinoxes. The Earth's axis completes one full wobble in approximately 25,920 years, and 25,920 divided by 600 equals 43.2. Two coincidences are interesting. 5 or 6 are a pattern. You do not encode pi by accident. You do not arrive at the Earth's dimensions through fortune. At some point, coincidence must yield to intention. The royal cubit as a knowledge system. The basic unit of Egyptian measurement, the royal cubit, measures approximately 52.4 centimeters. It is a precise, standardized unit. Cubit rods found in archaeological sites across Egypt confirm that the standard was maintained with high consistency across regions and centuries. This is not a rough approximation. The Egyptians had a highly standardized system of measurement. What is less widely known is that the royal cubit itself, when analyzed in relation to known astronomical and geographic constants, appears to encode specific knowledge. The Earth's circumference divided by the number of seconds in a day, 86,400, gives a result that is a simple multiple of the royal cubit. Whether this relationship is coincidental a consequence of the cubit being derived from an astronomical or geographic original, or simply a numerical accident depends on exactly how precisely you accept the ancient measurements. We cannot resolve this question with certainty, but the pattern of encoded relationships that researchers have identified in the pyramid's dimensions is extensive enough to require explanation. Either the ancient Egyptians achieved extraordinary mathematical sophistication and deliberately encoded it in stone, or an extraordinary sequence of coincidence aligned to produce the appearance of such encoding. Both possibilities are difficult to accept without discomfort. The message and its recipients. If the pyramid was designed to communicate, the question becomes, communicate what? To whom and for how long? Stone is the most durable medium available without modern materials. Papyrus lasts centuries at best. Wood lasts decades to centuries depending on conditions. Oral tradition mutates over generations. But stone, particularly hard limestone and granite, can preserve geometric relationships for tens of thousands of years without degradation. If you want to send a message across an interval measured not in generations but in civilizations, you build it in stone. Mathematics is the most universal language available. It does not depend on shared vocabulary, shared culture, or shared belief. The ratio of a circle's circumference to its diameter is pi in every culture, in every era, on every planet, around every star where geometry is understood. If you want your message to be legible to any sufficiently advanced recipient, regardless of their cultural background, you encode it in mathematical relationships. The pyramid, read in this light, is a compressed archive. Its dimensions store numerical values. Its alignments store astronomical data. Its proportions store geometric knowledge. All of this information is preserved in a form that requires no decoding other than the ability to measure accurately and recognize mathematical relationships. The message is not written in any language. It is written in geometry, which is the language of the universe. Whether this interpretation is correct, whether the builders actually intended this, cannot be confirmed. But the information is genuinely there. Researchers with good instruments can extract it. The pyramid does not merely claim to be a repository of ancient knowledge. It demonstrably contains ancient knowledge, accurately preserved, waiting to be read. The decline as evidence of inheritance. We return at the end to the decline. The pattern is more consistent and more widespread than is usually acknowledged. It is not merely that later Egyptian pyramids are smaller. The quality of stoneworking across all categories of Egyptian craftsmanship follows the same arc. The oldest work is the finest, and quality decreases as you move forward in time. The pre-dynastic stone vessels carved from diorite, basalt, and schist show a level of technical achievement that later periods could not match. Diorite is nearly as hard as granite. Carving a thin-walled vessel from diorite, with walls uniform in thickness and surfaces smoothed to a polish, requires either exceptional tools or exceptional skill, or both. The pre-dynastic Egyptians did it. Their successors, with more sophisticated cultural organization and presumably accesses to the same quarries and the same raw materials, produced cruder work. The diorite statue of Khafre housed in the Cairo Museum, is one of the most technically accomplished pieces of sculpture from the ancient world. The hardness of the stone, the precision of the carving, the quality of the polish, all of it places this work at or near the technical ceiling of what was achieved in ancient Egypt. It dates to the 4th dynasty. By the Middle Kingdom, 1,000 years later, comparable works in hard stone are rarer and generally less refined. By the New Kingdom, 2,000 years after the Old Kingdom peak, very large-scale stonework in granite and diorite has largely been replaced by painted limestone reliefs. The skill for working the hardest stones at the highest levels had eroded. This is the opposite of what we expect from civilizations. We expect improvement. We expect accumulation. We expect each generation to build on the last and advance the art. In ancient Egypt, in the domain of stonework, the trajectory runs backward. The oldest is the best. Everything after is decline. This pattern is not proof of inherited knowledge from a lost source, but it is consistent with it in a way that the conventional model of internally developed, continuously improving capability is not. Göbekli Tepe and the expansion of the possible. Before we close, we need to travel to southeastern Turkey, to a series of low hills near the ancient city of Sanliurfa, to a site that was discovered in the 1960s, but not seriously excavated until 1994, and whose implications for our understanding of human history have not yet been fully absorbed by the broader culture. Göbekli Tepe is an approximately 11,600-year-old complex of stone enclosures. Each enclosure consists of T-shaped limestone pillars, some standing up to 18 feet tall and weighing up to 10 tons, arranged in circles and covered with sophisticated carved reliefs of animals: foxes, snakes, boars, waterfowl, insects, and abstract symbols. The carvings are not primitive. They are accomplished, depicting animals in movement, with attention to musculature and detail. The site predates agriculture. It predates pottery in the region. It predates settled village life. According to every model of human cultural evolution current at the time of its discovery, it should not exist. The consensus held that monumental construction required agriculture because agriculture produced the food surplus that freed some people from constant foraging and allowed specialized labor. But the builders of Göbekli Tepe were not farmers, they were hunter-gatherers. Göbekli Tepe forced an immediate revision of the model. If hunter-gatherers could organize, coordinate, and execute a multi-decade monumental construction project at this level of technical and artistic sophistication, what else might have been possible in the human past that we have not discovered? Göbekli Tepe did not exist. Until it did. The Sphinx predates writing. Until perhaps it did not. The boundary of the possible keeps moving back. What lies beneath the sand, the Sahara Desert, vast and apparently featureless, has been systematically surveyed from orbit by satellite. Radar systems capable of penetrating dry sand to depths of several meters have revealed, beneath the surface, the outlines of ancient river channels, dried lake beds, and in some cases, structural anomalies that do not obviously correspond to natural geology. Most of these are unstudied, The logistical difficulty and political complexity of excavating in remote regions of Libya, Chad, Niger, and Sudan is considerable. We do not know what is under the Sahara. We know what the satellite images suggest, which is that the landscape beneath the sand is complex, varied, and almost certainly contains cultural material from the African Humid period that has never been found or studied. We know that human populations occupied this landscape for thousands of years during a time when it was habitable. We do not know what those populations built, or what knowledge they held, or what happened to it when the desert returned. We know almost nothing, and we have looked almost nowhere. The silence of the Saharan archaeological record is not evidence that nothing was there. It is evidence that we have not looked. The subsurface anomalies, ground-penetrating radar surveys of the Giza plateau itself have identified anomalies in the bedrock beneath the pyramids, anomalies that do not correspond to known chambers, passages, or natural geological features. Some of these show geometric regularity, rectangular patterns, evenly distributed voids that suggest intentional excavation rather than natural variation in the limestone. No official excavation has been conducted to investigate these anomalies. They are documented in survey data. Their origin remains officially unexplained. The Egyptian government, for reasons that include historical precedent, religious sensitivity, and practical concern about what such excavations might disrupt or reveal, has been cautious about authorizing deep subsurface investigation of the plateau. What is below the pyramids? We genuinely do not know. The honest answer is not that nothing is there, because the imaging data suggests something is there. The honest answer is that we have not yet looked, and we may not for some time. Two models, one reality. At this point in our examination, two models stand in tension. Neither is complete. Neither has been proven. The evidence supports elements of both and contradicts elements of both. Model 1, the conventional account. The Great Pyramid was designed and built by the 4th dynasty of ancient Egypt under the authority of Pharaoh Khufu between approximately 2560 and 2540 BCE. The knowledge used in its construction was developed within the Egyptian cultural tradition, building on the step pyramid of Djoser and earlier experiments. The workforce numbered in the tens of thousands during peak periods. The tools were copper, wood, and rope. The precision achieved was the product of exceptional organizational capacity, skilled labor, and accumulated practical experience that was subsequently lost through social disruption, resource depletion, and changing priorities. Model 2, the inheritance hypothesis. The Great Pyramid incorporates knowledge that predates the 4th dynasty by centuries or millennia. This knowledge originated in one or more earlier cultural traditions, possibly associated with populations that occupied the Green Sahara or the Nile Valley during the African Humid period, and was transmitted to the historical Egyptians through channels we have not fully traced. The 4th dynasty had the organizational capacity to implement this inherited knowledge, but did not fully understand its theoretical foundations. The decline in pyramid quality after the Fourth Dynasty reflects the progressive loss of transmitted knowledge that was never fully internalized. These models are not as mutually exclusive as they first appear. The Fourth Dynasty almost certainly built the Great Pyramid. The question is whether they did so with knowledge they originated or knowledge they received. These are different questions with different implications, and the evidence we have does not definitively answer the second one. The precision that has no purpose, we come back again to precision. Not because it is the most dramatic aspect of the Great Pyramid, but because it is the most inexplicable. The alignment to true north within 3 arc minutes, the foundation level to within half an inch across 13 acres, the joints between casing stones finer than a human hair, the granite surfaces in the King's Chamber flat to tolerances that modern machinists describe as requiring lapping equipment. None of this precision was structurally necessary. A pyramid that was slightly off north, slightly uneven in its foundation, with joints you could fit a finger into, would still have been magnificent, still have dominated the landscape, still have lasted 4,000 years. The precision serves no utilitarian function that we have identified. It is not required for structural integrity. It is not required for visibility. It is not required for the burial ritual, which could have been performed perfectly well in a somewhat less precisely constructed chamber. The precision exists for its own sake, or for a purpose we have not yet identified. Either possibility is unsettling, because the effort required to achieve such precision is immense, and immense effort without understood purpose implies a kind of knowledge about why that purpose matters that we do not share. The builders knew something we do not, whether that something was a technical secret, a theoretical understanding, or a belief system that made this level of precision sacred, we cannot say. We can only say that it was important enough to motivate one of the most sustained and precise construction efforts in human history. And then, within 2 or 3 generations, it was gone. The stone endures. The Great Pyramid will stand for a very long time yet. The limestone is hard, the granite harder still, and the desert air is dry enough to slow the processes that erode softer materials. Barring catastrophic geological event or deliberate human destruction, the structure will be recognizable and largely intact for tens of thousands of years. In that time, our civilization may develop the tools to finally answer the questions this structure raises. Muon tomography will improve, and we will see inside the pyramid more clearly than we can today. Subsurface scanning technology will improve, and we will see beneath the plateau without digging. Archaeological methods will improve, and we will be able to extract information from the bedrock and the sediment that we cannot currently access. Perhaps we will find the answers in the stone itself, encoded in proportions we have not yet measured, in alignments we have not yet traced, in materials whose isotopic signatures we have not yet analyzed. Perhaps we will find them underground, in chambers that current imaging suggests but has not confirmed. Perhaps we will find them in the Sahara beneath 30 feet of sand, in the ruins of a civilization that built its monuments in materials more perishable than limestone, and has therefore left almost no trace, or perhaps we will not find them. Perhaps the knowledge was truly transmitted rather than originated, and the original source was lost in a catastrophe we have not recognized, in a period so remote that the evidence has been buried, flooded, eroded, or simply not yet found. Perhaps the pyramid will continue to stand for another 4,000 years, answering the question of how long something can last, while declining to answer the question of who built it and what they knew. The stone does not need our theories. It has survived every theory ever proposed about it. It will survive ours as well. An honest conclusion here is what we know, stated as plainly as possible. The Great Pyramid exists. Its dimensions can be measured. Its alignment can be confirmed. Its mathematical relationships can be verified. Its geological context can be studied. The evidence from all of these sources creates a picture that is genuinely difficult to reconcile with the conventional account of when and how it was built, using only the tools and knowledge that the Fourth Dynasty is otherwise known to have possessed. Here is what we do not know. We do not know who designed the pyramid. We do not know the precise methods used to quarry, transport, lift, and position the stones. We do not know why the precision was considered necessary. We do not know whether the king's chamber was ever used for a burial. We do not know what the ventilation shafts actually point at or why. We do not know what lies beneath the plateau. We do not know the full extent of human cultural achievement in the period between 10,000 and 5,000 BCE, because most of the places where that achievement might have occurred are either underwater, under desert sand, or simply unexcavated. The conventional account is the best available account given the evidence we currently have. But the evidence we currently have is genuinely incomplete, in ways that are significant enough to keep the question open. History is not a closed book. It is a book being written, and the pyramid is a chapter we have not finished reading. Let your breathing slow again. Feel the weight of 4,500 years, not as a burden, but as a perspective. Every worry that feels large tonight is tiny against this scale. Every certainty that feels solid is provisional against the patience of stone. The pyramid was here before the Roman Empire rose, before Julius Caesar was born, before Socrates asked his first question, before the Trojan War. It was old before those things were new, and it is older still now. Somewhere in its granite and limestone, in its angles and proportions and alignments, is knowledge from a time we cannot reach by digging through the written record, because the written record does not go far enough back. It reaches back into a period that our history books summarize as prehistoric, implying that history had not yet begun. But human beings were thinking, building, observing the stars, and developing knowledge 10,000 years ago, 12,000 years ago. Further back than that, we are not the first people to understand things about this world. We may not even be the people who understood the most in every domain. The pyramid suggests, quietly and enormously, that there were minds before us who grasped things we are still reaching for, and they built their understanding into stone, where it would wait for us in the patient way that only stone can wait. Whether we ever fully understand what they knew is uncertain. Whether we deserve to, given how casually we have sometimes dismissed the evidence, is a question worth sitting with. The pyramid endures. The questions deepen. Sleep well.